All right, good morning, everyone. For those of you who took the SAT yesterday, I hope it went well. For our lesson for today, we're going to look at the inverse of an n by n matrix. So if you remember from our last lesson, we talked about the inverse of a 2 by 2 matrix. Today we'll look at how to find the inverse of a square matrix in general, for example, like a 3 by 3. And for you to do now, it's a reminder of, the formula that we saw for a 2 by 2. Here, I want you to find the inverse of this 2 by 2 matrix right here, 4, 5, 2, 3. And as a reminder, here's the formula. So it'll take like 30 seconds to do that, and then we will discuss. All right, so let me pause you here. So again, we're going to find the inverse of this 2 by 2 matrix using this formula that we saw from last time. And here is the solution. All right, would anyone like to explain how we arrive at this answer right here? So 3 over 2, negative 5 over 2, negative 1, and 2, that's the inverse matrix of A right here. Any volunteers to read or explain? All right, if not, then I'll go. All right, Grace?
Okay, so I just followed the equation. So 1 over AD, so that's 4 times 3, and minus BC, so 5 times 2. So that gives you 1/2. And then D, negative B, negative CA. So the matrix is 3, negative 5, negative 2, and 4. And then you just multiply that by 1/2, so divide by 2. So 3/2, negative 5 over 2, negative 1, and 2.
All right, very nice. Thank you for that. So yeah, for this 2 by 2, you just follow the formula as Grace explained, right? 1 over AD minus BC, you get 1 over 2, and then you work with the corresponding entries, right? Switch the diagonals, negate the other two, and you get this. Okay, so that's our answer for our do now. Leo, question?
Could you scroll to the purpose for a second?
The aim?
The aim.
Okay, yeah. Just how to find the inverse of an n by n matrix.
All right, thank you.
Yep.
I'm good.
All right, does anyone still need the solution to the do now? All right, now I'll move on then. So let me just give you an overview of the rest of the lesson. We're first going to talk about the procedure, right? The inverse of an n by n matrix. And as you'll see, we're going to use Gauss-Jordan elimination. That's going to be followed up with this example here, and then just a practice question. Okay, so here's a slide for that. And can someone read this slide here, please? All right, we'll go to Joel and then Suhani, and then Leo and Syed for the next ones. So Joel, can you read this part?
Okay. The inverse of an n by n matrix. The procedure is the following. Augment the matrix with the identity matrix. Use Gauss-Jordan elimination to row reduce the left side into an identity matrix. The right side is then the inverse of the original matrix.
All right, thank you for that. And then Sahani can read the note right here.
Note, if we encounter a row of zeros on the left half when trying to find an inverse, then the original matrix does not have an inverse.
All right, thank you for that. So yeah, so as you can see, right, we're gonna, so by augment, we just mean like, kind of like combine them. So we're gonna combine the two matrices. The matrix that we're trying to find the inverse for with the identity matrix. If you remember the identity matrix, that's like the number one, quote unquote, matrix from, I think 2 lessons ago. Or maybe Monday. But anyways, the identity matrix is like I2, I3, right? We have like the ones along the diagonal and then zeros everywhere else, depending on like what the matrix we're trying to solve the inverse for is, right? So if it's 2 by 2, then we augment it with I2. If it's 3 by 3, then we augment it with I3. And then step 2 is use Gauss-Jordan elimination to row reduce the left side into an identity matrix. So we're essentially going to transform the left side, and this will be clear once we see the example, but we're going to transform the left side of the augmented matrix into an identity matrix, and then the right side will become the inverse of the original. And something to note here, as Sahani read, right, if we encounter a row of zeros on the left half, when trying to find an inverse, then the original matrix does not have an inverse. Okay, so just keep that in mind. One of the two examples that we'll look at today actually does not have an inverse. Okay. But yeah, so if you remember when we were doing Gaussian and Gauss-Jordan elimination, I told you that like Gauss-Jordan is less efficient, right? It requires more steps, but there are a few cases where we actually have to use Gauss-Jordan rather than Gaussian, and this is the example. This is one of those cases that I was mentioning earlier. Okay, so we have to use Gauss-Jordan elimination in order to find the inverse. All right, does anyone still need to copy this slide here? Okay, if not, then I'll move on. So next is the example. And yeah, we're first going to find the inverse of this matrix, 3 by 3. And then for our practice question, we'll find the inverse of a 4 by 4. Okay. All right. So all right, this solution is quite long because, again, we're using Gauss-Jordan elimination, so that's like the longer process. Let me zoom out for this. Okay, so we're finding the inverse of this 3 by 3. So we augment this matrix here to I3, right? So I3 is the identity matrix for 3 by 3. So we have the ones along the diagonal and then zeros everywhere else. Okay. So Gauss-Jordan elimination, right? We want reduced row echelon form. First thing I'm going to do is get a 1 in the top left corner. So I'm going to switch row 1 with row 3. We're going to get 1, 0, 1, 0, 0, 1 on the top, the first row. And then row 3 becomes, row 1 becomes row 3, right? So that's 4, 2, 3, 1, 0, 0 here. Row 2 stayed the same. Okay, so next I want a 0 in place of the 3 here, and a 0 in place of the 4, right? Because we want zeros in the first column under the leading entry of 1. So to do that, I'm going to do R2 minus 3R1. Negative 3 or 1 I wrote down here. That's negative 3, 0, negative 3, right? Just multiply the first row by negative 3. You get negative 3, 0, negative 3, 0, 0, negative 3. And you're going to combine that with row 2. Okay, so 3 minus 3 is 0. 3 plus 0 is 3. 2 minus 3 is negative 1. 0 plus 0 is 0. 1 plus 0 is 1. And then 0 minus 3 is negative 3. Okay, so that's row 2 now. Next, we also want a 0 in place of the 4. So for that, I'm going to do row 3 minus 4r1. Okay, and for that, right, negative 4r1 is negative 4, 0, negative 4, 0, 0, negative 4. And again, we're going to combine that with row 3 here. So 4 minus 4 is 0, 2 plus 0 is 2, 3 minus 4 is negative 1, 1 plus 0 is 1, 0 plus 0 is 0, and then 0 minus 4 is negative 4. Okay. All right, so now we have our zeros in the first column. And next we want a 1 here, right? So we want, the ones along the staircase pattern, right? So the ones along the diagonal, and then zeros everywhere else. Okay, and for that, I'll do R2 minus R3. Okay. But yeah, let me give you some time to copy this, and then I'll continue with this step. Okay, so let me keep moving. So again, we want a 1 in place of the 3 here, right? Because we want the staircase pattern in the 1s. So we could technically divide by 3, but I won't do that because that'll introduce fractions here. So instead of doing that, I'm going to do R2 minus R3, right? Because R2 minus R3, that'll give us a 1 here, right? 3 minus 2 is 1. So I'll do that. So 3 minus 2 is 1, then negative 1 minus itself is 0. 0 minus 1 is negative 1, 1 minus 0 is 1, then negative 3 minus negative 4 is 1. Okay, that's row 2 now. Okay, so now we have our 1s in the, right here and over here. So next, I'm going to deal with the second column. We want a 0 in place of the 2. And for that, I'm going to do row 3 minus 2r2. Okay, minus 2r2 is written down here. That's 0, negative 2, 0, 2, negative 2, negative 2. And I'll combine that with row 3. So 0 plus 0 is 0. 2 minus 2 is 0, that's what we wanted, right? We want a 0 here. Negative 1 plus 0 is negative 1. 1 plus 2 is 3. 0 plus negative 2 is negative 2. And then negative 4 plus negative 2 is negative 6. Okay. So we're almost done with row echelon form. Next we'll do, and then after that we'll do reduced row echelon form, right? But yeah, where we left off was here. So negative 1 times R3. I want to, instead of a negative 1, I want a positive 1. So I just multiply by negative 1, right? Easy enough. We get 1, negative 3, 2, 6. And then luckily for us, there's only one more step to complete the Gauss-Jordan elimination, right? So we have our 1s here. Right now this is in row echelon form, right? So technically we have completed Gaussian elimination, and we want a zeros everywhere else to complete Gauss-Jordan elimination. And the only thing that's not a 0 here is this 1 right in the top, in the top row. So for that I'm going to do row 1 minus R3, right, to get rid of that 1 here. So row 1 minus R3, that's 1 minus 1 is 0. 0 minus negative 3 is positive 3. Careful with the negatives. 0 minus 2 is negative 2, and then 1 minus 6 is negative 5. And that completes our Gauss-Jordan elimination, which means that we now have our inverse matrix. It's this matrix on the right here. which is 3, -2, -5, -1, 1, 1, -3, 2, and 6. Okay, that'll be the inverse matrix of A. And remember, the original matrix was right here, right? 4, 2, 3, 3, 3, 2, 1, 0, 1. All right. Does anyone still need to copy the solution here? Okay, if not, then I'll move on. So with the time remaining, we will start this question right here. So for that, let me go to Leo. Can you read this question for us? You don't have to read the matrix, just read the words.
Find the inverse of the matrix using the procedure you just learned.
Okay, thank you for that. So this is a 4x4 matrix, and the procedure that we mentioned here, that's just like, you know, procedure we just performed, right? Augment the matrix. In this case, that'll be I4, right? One's along that diagonal, 0 everywhere else, and then we use Gauss-Jordan elimination to find the inverse. Okay, and as I said earlier, right, one of the two examples that we did will have no inverse, right? And since we already completed the first one, yeah, this one will have no inverse, and you'll see that, you know, there's a row of zeros on the left half, and that actually has to do with the determinant, which we might cover in a later lesson. I'm thinking about skipping it, but yeah, that has to do with the determinant, right? If you remember from like Monday's lesson, like the determinant is like AD minus BC for a 2x2. If that's 0, then there is no inverse, right? Because in the 2x2 formula, that's 1 divided by 0. And that'll be undefined. Anyways, so let me start off with the solution here. So again, we're going to augment the this matrix here with I4, right here. And then we're going to use Gauss-Jordan elimination. Okay. All right, so first I'm going to do row 3 minus row 1, right? Because I want zeros in place of in place of 1 here, and in place of this 1 here also. So row 3 minus row 1, it's 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and then 0 minus 0 is 0, 0 minus 1 is -1, 0 minus 0 is 0, 1 minus 0 is 1, and then 0 minus 0 is 0. Okay. And so technically, so I think this is easy enough to do R4 minus R1, but I just wanted to, you know, show everything, you know, step by step so that, you know, you don't get lost in this new method. But yeah, feel free to, if you can do it, you know, just write R4 minus, I would do R4 minus R1 in the same step. And then, so you don't have to rewrite like another 4x8 matrix again. Right. But yeah, that's what we'll do next. R4 minus R1. So instead of the 1 here, right, we want a 0. So for that, I'll do R4 minus R1. So for that, 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0 again. 1 minus 0 is 1. 0 minus 1 is -1. 0 minus 0, and 0 minus 0 in the next two columns. We have 0, 0. And then 1 minus 0 is 1. Okay. All right, so that's this now. And then as you'll see in the last step, we're going to do R4 minus R2, and that'll give us a row of zeros in the left half on the bottom row, right? Which means that this has no inverse. Okay, so let me finish the last step. So it's R4 minus R2, right? And yeah, technically we, I guess with normal Gauss-Jordan elimination, we would do, row 3 first to get rid of that 1 here and make it a 0. But since I saw that this is 1, 1, and that will allow us to show that this has no inverse, I just decided to go with that. Okay. Anyways, row 4 minus R2, that's 1 minus 1 is 0, and then 0 minus 0 is 0, 1 minus 1 is 0 again, and then negative 1 minus 0 is negative 1, 0 minus 1 is negative 1, 0 minus 0 is 0, and then lastly 1 minus 0 is 1. Okay, and as we can see here, right, since the bottom row of the left half of the matrix is, well actually let me call on Syed for this. Syed, can you read this answer for us, please?
Yeah. Since the bottom row of the left half of the matrix is all zeros, the matrix has no inverse.
All right, thank you for that. So yeah, as we can see here, the bottom row of the left half, that's this right here, 0, 0, 0, 0. So left half is in like, this is a 4x4 augmented with a 4x4. This will have no inverse. Okay, Ram?
I have a question. So let's say one of the steps is subtracting R3 minus 3 times R2. Would we have to also change R2 as well, or can we just keep R2 the same and just subtract R3 minus 3 R2 by only changing the third row?
Yeah. So that's actually, yeah. So that's how we do matrix operations, right? Like you don't have to change the row that you're multiplying. So like R3 minus 3R2, I think you said. Like you wouldn't have to change R2, right? Yeah.
All
So yeah, you only change the row, one of the rows, right? Okay. All right. Yeah. Any other questions? Okay. All right. But yeah, let me close with announcements. So first, there's SGI today, per usual, 247. And the other thing would be, I guess, the quiz. If you haven't left a comment on quiz 8 yet, and you want me to grade something manually, please do so as soon as possible. Okay. All right, but yeah, other than that, if you have no further questions, you're free to go, and I will see you all tomorrow. All right, take care.
Have a good day.
Thank you.
All right, thank you.
Thank you.